Good morning, everybody. It's Marty the JavaScript Party and my buddy Rhett. I just realized I forgot to get her a nut, and that's because today is a bit abnormal because it is Tuesday the 17th. And on Tuesdays, I normally don't bring Rhett out because Rhett is, because that's when my daughter-in-law usually brings her dogs. But my wife is not feeling well, so she called off. So she's the boss lady, so she calls off and just tells, her employees don't bother coming in today. We don't for whatever reason, she will often have reasons. It doesn't happen very often, maybe a couple times a year max. But so the dogs aren't coming, so I brought Red out. I'm also running a little late. It is already 8:44. So anyway, so someone once said that I've only had a handful of comments ever on any of my videos, so it's kind of easy to remember them. But someone once said that the reason they liked my videos was because I always kind of re-explain everything from the beginning at the beginning of every video. Um, and I realized that this is actually what I do at work. Every time I change tasks, I actually go through an internal dialogue exactly like what I'm going through right now. So that is neat. Let's see. So we are working on trying to get a table that shows all of our entities. So basically, if you hit F12 and you hit this, you'll see that we have this entity here. And then there's 7 of them right now, and I have it broken down in different ways. And this is one of them. And I was using this as a pretty good tool. It made a huge difference for me. But I felt like it would be better to have an actual table. And the only reason is because I want to be able to write end-to-end tests that sort of validate what I do. My sense is that as this thing starts to become more complex, trying to understand what's happening is going to be difficult, and trying to make sure I don't break things when I fix something is going to be doubly difficult. And that is where I found end-to-end tests really shine, is you've locked it. It's a great way to lock in features, right? So the feature works. We know it's working. It's tested. We have an end-to-end test for it. And then we make some more code changes. We run the end-to-end test. If the end-to-end test fails, we know we broke the feature. It's just so easy to forget features once you're working on a new feature, you've focused on the new feature. You sort of focus spotlight on that new feature and all that. So anyways, we ran into a bit of a problem, and the problem was is we could not effectively get this information to update on the screen. And so basically, I came up with this idea that I would do a hash on this code, and then also publish the hash, and then my effect would recognize if the hash has changed and rerun. And the hope was that when it reran, it wouldn't try to use some old version or whatever, or wouldn't try to say, hey, I've already updated this, so it's not marked as dirty or something like that. Like the hope was that it would work, and sure enough, it did work. Now, this definitely solidly falls under the category of an undocumented feature. So, like, there's no guarantee that in the future that like if I do an Angular upgrade, that they won't add some additional optimization code that catches the fact that I haven't changed the reference of the object that it's referencing. Like, there's nothing, that is a very low level implementation detail that the browsers and Angular and all them have come up with, and it happens to work in my favor. Now, it doesn't mean it's always going to work in my favor. I could very, very well do an upgrade and this just quit working because the Angular people said, "Oh, okay, we're going to write additional code just to make sure that we're not doing unnecessary DOM updates," and then I'll have to figure something out if that happens. Um, but if nothing else, even if I have to blow away and bring back the entire data structure that has all this information in it, at least I'll only be blowing it away and bringing it back when there's an actual change, as opposed to all the time. So it's still a step in the right direction, even if in the future this breaks after an update. And it would not surprise me at all if I do an upgrade. And then that's also another wonderful benefit of the end-to-end test is the end-to-end test would catch that that the update's no longer happening, because it would go back and try to add something and see that there's no new data, and it would be like, hey, this is broken. And then it's on me, right? I could choose to either not do the update, or I could choose to do the update and fix the issue. But at least I know, as opposed to like rolling it out there and finding out that some table is no longer updating. So, anyways, now we're about to change gears completely, and we're about to go into like understanding how Angular material tables work. And it's just so an absolutely different mindset completely, and just a huge contextual change. And but we see that we do have this console log, and I don't think this console log is bringing any value. Um, Now, it really behooves you um, to create like a table data sort of thing, and that table data, and then have like a transformation, and then the transformation takes your raw data and converts it into something that will look better in the table, um, as opposed to like sort of using the natural JavaScript goodness that kind of handles these sorts of things on its own. Um, because JavaScript is just really good at just taking data that you throw it at and figuring it out what's supposed to be in there, um, which is can come in really handy, especially right at the end of a project when you're trying to get stuff done. But it's hard to use that as like a foundational piece. Um, so anyway, so we have our keys, and that's our string, and that is I don't even know what that. Oh, that is the actual ID of the values. So these are, I guess what we'll do is we'll just hit this. Yeah, see, 1, 2, 3, 4, 5, 6, 7. These are the IDs. So let's go ahead and just change this to IDs. And these are STIDs specifically. You will learn one way or another, you will learn that naming things in a like being very thoughtful about your naming of things is um, makes so much difference. IDs, like if you want to help your future self out, you will name things in a careful. You will carefully name things. And so it's 8:51. All right. So basically, we want to create a table, and our table, and we want to use. I want to use material tables, and the biggest reason I want to use material tables is for one special thing. Well, there's a lot of reasons, but Angular material. One of the things I really, really, really enjoy about. So, like me and Angular material, I would say, and I would bet everyone I know is kind of falls under this category. But me and Angular material are frenemies, right? I really like it a lot, but it also pisses me off on a regular basis. There's a table version, table, and so here's a good example of a table. I believe there's, and that is nice. I think it looks nice and all that. But the thing that I really like about tables, which I don't plan to implement at this point, but but maybe I will. But at this point, I don't see myself. Oh shit, I don't know. Maybe I will. Is it this? No, this is so that you can move them, which that's pretty nice. Um, let's go to the examples. So the thing that I have found is just beloved throughout the entire industry is, where are you? These guys, yeah, secondary roles, but more like um, expandable secondary rows. I'm trying to find one. It's been a while. Oh, damn! Look at that thing. It's kind of weird though, because Angular tables, like these tables, what is this one? What does this do? Um, what is that even called? Table with design ripples. Oh, look at that. Um, there used to be like examples of ones where you'd click on it and it would open up. And I don't see that right now. This is annoying. See how like this one has, there's one up here that had like this, where it had like a secondary row, but I've seen them where the secondary row is hidden unless you click on it. And then the secondary row appears, and I really like that. But I don't know, it doesn't look like there's any examples of that anymore. I don't know if it's something, maybe they moved away from that idea. Oh, here we go. This is exactly. See how this is so nice. Um, and that is sort of the that's you could do that. You could build that out. It's not the end of the world to build that out, but boy, it sure is nice in Angular material. Um, so anyways, in order to start, we need to, I guess we should go to examples and then just do a basic one. So but the first thing is we do need the mat table module before we do anything. And see how we have this interface, and that interface describes how we want the data to look in the table. So that'll be like the second thing we do. And I feel like it makes sense to have that interface in here, but I don't see any reason to export it. If you're going to export it, it seems like that should be in its own little thing. I think that is a bit misleading. But anyway, so first thing to do is to bring in the um, mat table module. Mat table module. Let's see if it knows how to find it. Nope. I think I had pasted the import up here. Yeah, there we go. I think once you've found one material thing, and then when you start adding them, it can find them, but it does need a little bit of a hint, I guess. All right, so now we have our module. Okay, so it looks like our second thing we want to do is create an export. I mean, an interface. So let's go ahead and export. Um, and these are called entities. So I'm going to call this my tabular entity. And I'd like to put my interfaces after. Probably makes sense to put them before now that I think about it, but so I don't want to export it. If I'm going to export it, I want to move it into its own thing. So let's see. ST table record. And it's going to have an ID, and I believe that's a number. And I'm going to call it an STID. And that's a number. An ST name. Or what all do we have in here? 12. So we know they all have an ID. Oh, they all have a type. They have an ID. And then that's really the only thing they have in common, and everything else after that is very unique. So type is a string. And for now, that's all I'm going to capture. So I want to transfer this ST entity table record, and then what I want to do is create an array of ST entity table records. I'm just going to call them table records. I don't see myself ever being in here going like, oh, is this for ST or but maybe in the future. But if we do get to that point, I definitely want to be able to like mentally sort of process that. Okay, so now we probably, and I don't even know exactly what the best way to do this is, but I'm going to do a table transform. Just gonna create a function called table transform, and it's going to accept a array of sequence dictionaries. That's going to return an array of table records. T entity table record. It's going to return an array of those. And for me right now, I'm just going to return an empty array at the moment, just so it'll transfile. So basically, we're going to say like this dot table records is equal to transform, and then we're going to pass it in. Let's see. What are these? These are called, this is called a sequence dictionary. It's going to take a sequence dictionary, which is of type sequence dictionary, and it's going to return an ST. So it's just basically do all the transformations so that we have our data in a way that is a little bit easier to deal with. Which basically for right now, all it does is going to do is pull the STID. Okay, the STID. And see, that's the other thing that gets confusing on this is there's more than one STID in many of these things, but I want that record's unique identifier, not any of its references. Get the type. And that could get confusing in the future. So getting that clear now is good. Ooh, shoot, it's 9:01. Gotta go. Bye. Have a great day.